building on the conclusion we made in the last video, that if I have a pencil, you add those pencils together first. Right? And say you have an eraser. You consider this separately, whatever numbers you have, say you just have two of them. You add this separately because each of this has different pricing. Each are of different numbers. Now, a quick question. Can you add 3 apples and 2 apples to get a single number? Use the same funda. So can you tell that I have 5 apples? Is the question. Yes or no? Correct answer is yes. What about if we have 3 apples and 2 oranges? Can we add them to get one number? If we have 3 apples and 2 oranges, can we make them as 5 apple orange? Is this even possible? Don't tell me I'll take a blender and this is the answer. Nope, I'm not talking about that. Answer is no, right? There's no such thing. We can't add this. Now, what if we use X instead of apple and Y instead of orange? So basically, this would be 3X and 2, same question. But instead of apple, let me do this actually. So what I'm doing is, I'm taking the same expression. Okay, putting it over here. We have 3X and 2X. So whatever logic we used over here, say 3 apples and 2 apples. Instead of apples, I'm writing X. Actually, let me use this. So 3X and 2X. Okay, yes, let me use X itself. Proper. So this is equal to 5X. Now, instead of this, I'll use X and Y. This is our answer. Instead of apples, we are using X, and oranges, we are using Y. So X and Y. So 3X plus 2Y. Can I add 3 apples and 2 oranges? Answer is no. We have to stop here. And that's the whole funda. Okay. So basically what we looked at over here from this is that whenever we got apples, we were able to add. When we got apple and oranges, we were not able to add. Can I come to this conclusion? So here we could add. Here we couldn't add. So what we're learning is something called as like and unlike terms. Simplifying algebraic expression is like tidying up a messy toy box. We group and add or subtract terms which are of same letters like X or Y to make the expression shorter and easier to understand without changing its value. Simplifying makes expression neat and easier to use in mathematical problem. So basically, instead of writing 3x and 2x, that is 3 apples and 2 apples, I can write it as 5 apples. So as a definition, like terms are terms which have the same variables and same power. So this might be new to you guys. So let's keep that apart. But as a definition, you should know that like terms are with different variables or powers. Simplification is a process combining like terms using addition or subtraction to write an expression in its simplest form. So this is an example of simplification. Okay, so this is an example of simplification. And this two are like terms. 3x plus 2y are unlike terms. Why? Because they have different variables. And so we can tell that they are unlike terms. So let's practice some bit of questions. So pause and try doing it. Again, you can apply this to addition or subtraction. It won't matter. So this is very clear. You have 4a and 3a. These are like terms. This is unlike term. So this will lead to 7a plus 2b. Now, what to do over here? So we have the terms, but what to do? If you guys remember, we can use a topic that we just learned few videos back. That is commutative property. Okay, so I shifted the terms around. Remember, variables are nothing but numbers hidden. So how numbers could be shifted with these symbols, with the signs, here too we can shift. So this we used with commutative law. And so this will be 2x, right? These two are like terms, plus 2y plus 4y. So here I'm using board mass, that is solving from left to right. And 2x plus this is 6y. So these two are like terms, and yeah. So can you please pause and try this? Now you guys have a hint at how these problems are. First, I will shift the terms around using the commutative law. And now I can see these terms are same. So this is 12m and these terms are same and this is 2n, and that's the answer. So you might have seen that I wrote the answer directly, as in I took an extra step over here. Since it's very clear what are like terms, you know the result, you can skip that extra step, and you can directly write the answer. That's it. These are your like terms and unlike terms. I think I have one more final conclusion. No, that's it.